In this episode, we're going to cover a concept we haven't yet covered in Go called mutation testing. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. Mutation testing is a concept where once you've written tests, you run a mutation testing framework over your code. This runs your tests and then mutates a small amount of your code, looking for tests to fail. If tests don't fail, then a mutation is said to escape. Mutation testing helps you to ensure that you have covered all possible scenarios in your testing. In today's video, we're going to use a mutation testing framework for Go called GoMuteSting by Marcus Zimmerman. Let's look at the code. When we run mutation testing, it can make lots of alterations to different parts of the code. In today's episode, we're just going to look at it changing the logical operators around testing the size of integers. We'll start by creating some tests, some functionality for our myInt struct. And then once we've created those tests, we'll run the mutation testing framework over our code to see if we've missed any logic or any tests that would ensure that our code is more robust. We're going to start by creating this myInt struct, which will have two functions. It will have a greater than function and a less than function. Let's start driving out the implementation of these two functions. Create our first test. myInt suite test not greater than. Okay, so I is new myInt 9, and then we'll do s dot false I dot greater than 10. Okay, so we can already see that our tests won't run because we've got new myInt function doesn't work, which is meant to return a struct which doesn't exist, and a function on that struct that definitely doesn't exist. So let's go through and let our IDE help us to create those functions first. Okay, let's do quick change. Let's move this into test, and then that's mutation dot myInt again. So import mutation. No. Oh. No, it doesn't like that. So we can do func new myInt takes an int, which is the value, and returns a myInt. So it's a struct. It has v int, and then we return myInt passing v. Wrong way around. Better. There we go. Okay, so that's that first line green. So now we just need to add this method. So myInt takes I, which is an int, returns just the ball, not the interface. So return true to make it. Oh, B. Yeah. Okay. So now we can run our test. So we'll do go test. Running our test has failed because line 20 should be false, but we got true because of our hard coding. So we can just quickly fix this. We can do return false. So, okay. So that's the first part of our greater than test complete. Eyes. In fact, let's do a little refactor. Is greater than, and then let's refactor this. Oh, did that not? Yeah. Ah, is, and then let's refactor the value as well, make this a bit nicer. 9, so it's really readable. Make our test nice and readable. So we create our myint called 9 with a value of 9, and then we say 9 is greater than 10, which is not, so it's return false. Okay, and then we can now move on and create our function to test when it is greater than. Test sweet test is greater than. Okay. So take our 9. Now we want to assert that it's true when 9 is greater than, let's say, 8. We can run our tests again. Okay, so our test is failing on line 26, which we would expect, saying it should be true, so we got false because of our hard coding over here. So now we have to actually write the logic to check whether the number we're given is greater than the number we hold. So we can say return I dot value is greater than the given value. Okay, so hopefully this will make both our tests pass. Let's see. It does. So we've now implemented our greater than functionality. We've got two tests. We've got one where our number is not greater than the check number, and one where it is greater than the check number. So now we can move on to our less than functionality. So we can do a new test. So, test suite not less than. Okay, so we can take out int 9 and we can do s dot false 9 is less than plus 8. So our IDE is already telling us that a function doesn't exist, so let's let it create it for us. Int v int. Okay. So return true, so it will run, save, let's run this. Okay, so our test is failing. We're expecting false, but we're getting true. So we can just fix this really quickly with return false. Okay, so now we're going to move on again, and we're going to add another test. My sweet test is less than this time. So we'll take our variable 9 and we'll check for true, where 9 is less than 10. Save. And let's run a test. So it's now failing on 938, which is our new test. So it should be true, but we're getting false. And this is because of our hard coding again. So now let's go and change I b is less than the given value. Save. Let's see if that passes all our tests. Great. So we're now back to fully passing a set of tests. So now for less than, we're checking when the value is less than and when the value is not less than and is less than the given value. By the looks of it, if this was all our int struct did, we've completed the implementation. Everything is now working. We've tested all of the kind of scenarios, less than and greater than, and not less than and not greater than. So we're good. So now's the opportunity to run our mutation testing framework over the code and over the tests we've created. So just to go over what mutation testing does is mutation testing takes the tests and runs them, makes sure they all pass. Then it goes into our code under test and it makes a small change to the code under test, and then it runs the tests again. And when it makes a change to the code under test, it expects a failure of a test to show that you've covered all the bases of if there was a mistake in your test, or just make sure you've kind of checked all of the possible scenarios of the testing each of your functions in this case. So what we're looking at today is we're just going to look at, hopefully, what our mutation testing framework will show is we've missed some tests around what it will do when it changes the logic operators here between the two numbers we have, the two ints. So hopefully it will change those and some tests won't fail, meaning we've missed some tests. So let's run our mutation testing framework. So we're going to run GoMuteSting across all of our project. So let's have a look. We do have 2 failures. And let's have a look. Okay. So the failure is it's changed our less than symbol to less than or equal. That's one of our failures, and we'll look at the other one. And very similar, it's changed our greater than symbol to greater than or equal. So this is showing us that we've missed some tests at this point. We've missed some scenarios about greater than and less than within our tests. And what we've missed is we've missed checking what our function does if we provide it with the same value. So we can say, we can add a new test here for our less than. So let's try that. So new test equal not less than. The naming's not done great on the naming here, so we can say that 9 is not less than 9. Save. Let's run our tests, make sure our tests are still passing. They are. Okay, so let's do the same for the greater than test. So new test int test equal not greater than. Okay, we can do the same. So we'll take this and we will check that 9 is not greater than 9. Test again. Okay, and now we'll go back to running our mutation testing to see if we've fixed all our escaping mutants. Cool, and we have. So our score is 1, which is, in mutation testing, it's a perfect score. That's a quick overview of what mutation testing can give you. It's a really good way to see where you have potentially missed some tests, so that you can be comfortable you've covered all of the potential scenarios for a piece of code. Now this is a very simple example, it's very small, and the reason I picked this is because it was very clear to show you what mutation testing does, and in fact it's changed our logical operators, and it shows you, it highlights very quickly what the problem is. But there's lots and lots of different things the mutation testing framework can change. So what I recommend is you have a play with mutation testing, have a play with GoMuteSting. It's very easy to install on your laptop and run against one of your projects to see what it does. If you're starting a new project, then you might want to consider starting with, from the scratch, using GoMuteSting as you are test driving your application, to enable it to help you see tests that you have missed. This might be a great way if you're learning TDD to see kind of where you're missing tests, to kind of see, to highlight to you where you're missing things, or where where you're not thinking of all of the possible scenarios through a function. So that's a really great way to play with it. Another great use of it is if you're coming on to picking up some code that you've not worked on before, that you've not owned. If you're coming into a new job or you're inheriting some code from somewhere, then running mutation testing over that code might show you where you might want to maybe pick up and put some more testing if you're missing things. Because if we take out, actually we'll do this quickly, if we take out those two functions, so equal not is greater than and equal not less than, if we let our IDE run our tests, and we're going to run it with code coverage turned on. So what you can see with these green bars here is all of the functionality. So we have 100% code coverage, but we still have the potential for things to break, for things to be wrong, for mistakes to be made. So with our current test, we could quite easily have accidentally added that equals as we were just coding around and just not kind of concentrating on other things, or just not thought about accidentally adding the equals and making it greater than or equal to, which actually changes the logic of our test. One of the great things about mutation testing is it kind of it's a thing that, so a lot of people aim for 100% test coverage, and if you're writing all of your implementation test driven, so you don't write any code before you write a test, there's still possibilities that you're going to miss things. And obviously TDD practice sweeps a lot of the bigger bugs under the carpet, so you're not going to hit those. You're going to, you know that you can be confident with your deploys because you've test driven everything. All code has been written with a test telling you to write that code as we've done with our integer class, but we still missed tests. We still kind of missed those slightly, miss some tests that would actually make our logic even more robust, and give us even more confidence when we deploy. So what I would say is run this on all your projects to get used to it, to see if you're doing some refactoring of a class, then it's a good opportunity to see tests that have missed, and you can add those tests and increase your mutation testing score. What I would say is if you are starting a new project and you're using it, then maybe you want to set a level that you want to. You could say, I want a perfect score. I want to say, you could kind of break your CI could break if you have an escaping mutation test. I wouldn't recommend doing that on an existing project. Maybe what you could say is, okay, the current level is this, and we won't go below it. But don't aim for perfect mutation testing score on some existing code, because the chances are you've probably missed some tests somewhere. I hope you enjoyed this video, and I hope you enjoy going away and playing with GoMuteSting and mutation testing. That's all for this video. I hope to see you again soon. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Braddle.